Hello and welcome to the video on one-hot encoding. We will first understand what is one-hot encoding using some examples. In fact, we will be looking at 3 examples, and at the end we will have a Pytorch code that performs one-hot encoding. To get an overview of one-hot encoding, we start with a fabricated dataset which we call as the car dataset. This has information on the brand, the model, and whether the car is a luxury vehicle or not. The features brand and model have names as values, and the feature luxury denotes the class label with possible values yes and no. Now, why do I call it as a class label? I am borrowing the terminology from classification. When we perform a classification task, we are saying that finally the classification should be yes or a no class. And that is the reason I term it as a label and not just as a name. In machine learning, the most important entity is the data set, and a data set is composed of multiple data where the data can be of different types. A common data type that we encounter in data sets is the categorical data. When we say a categorical data, it has a limited number of possible values that it can take, and it is surely not numeric. Categorical data can either be nominal data or ordinal data. We say that a data is nominal when it represents names and labels. Let's see examples for these. For example, Benz, BMW are all names, and if I try to get the class label as happy and sad, I call it as label. But when there is an implicit ordering of the items in the data, the possible values of the data, then I call it as an ordinal data. For example, let's say we're looking at the dress size. The dress size is XS, S or L. I know that S is a value in between XS and L. And when I look at the grade, S grade is considered higher than A grade, which is considered higher than B grade. So there is an implicit ordering of the items there. This ordering is not present in a nominal variable. So now we have a data set which has names and labels, but machine learning models require the input to be numbers. How do I give the brand, luxury, and model in a machine learning model as a numeric input? Let's look at it with the help of brand and luxury first. The solution to our problem is one-hot encoding. That is, I want to convert the names and the labels to numbers using one-hot encoding. Before we understand how to do one-hot encoding and what is one-hot encoding, we will define the word vocabulary. Let's take the attribute brand. There are 5 rows and there are 4 unique values. That is Audi, Mercedes-Benz, Ford, and Toyota. This is the vocabulary of the attribute brand. Now, similarly, there are 5 rows, but if you consider the values inside the attribute luxury, it is either yes or a no. And so the vocabulary of luxury attribute is composed of only 2 items, namely yes and no. To summarize, vocabulary is the set of all the unique names or labels in an attribute. One-hot encoding uses bits to represent this categorical variables. Here our vocabulary is composed of 4 names: Mercedes-Benz, Ford, Toyota, and Audi. Now we are going to represent them using bits. Since there are 4 possible values in the vocabulary, we are going to use 4 bits. As the first step, we looked at the vocabulary. Now let us order the vocabulary items in alphabetical order: Audi, Benz, Ford, and Toyota. And let us give them an integer number 1, 2, 3, and 4. We will use 4 bits such that Audi will have a 1 in the first position and a 0 in the remaining 3 positions. For Benz, we will have a 1 in the second position and a 0 in the remaining positions. And for Ford, it will be a 1 in the third position and a 1 in the fourth position for Toyota. Remember, there is exactly 1 1 and every other bit is a 0. What if there are only 2 possible values in the vocabulary? How many bits should I use? If you correctly answered 2, well done, your answer is correct. The attribute is luxury. The vocabulary is composed of yes and no. So I will call yes to be the integer 1 and no to be the integer 2. Since there are only 2 integers, I will have only 2 bits. Whenever it is a 1, I will have a 1 in the first position, and whenever there is a 2, I will have a 1 in the second position. We have seen one data set which had multiple rows and columns of categorical data. Let's see another typical example which we will see if we do computer vision. Assume we are performing computer vision in which we are giving multiple images, and looking at an image we want to classify whether the bird is flying, if it is pecking, or if it is sitting. So from the image we are expected to identify these 3 classes. So typically, even if you say identify from the 3 classes, the data set will have the image path and the corresponding class. Let us try to convert the class labels into one-hot encoding. The vocabulary is composed of flying, pecking, and sitting. In reality, when we convert them into integers, we actually convert them to integers starting from 0 to n minus 1. So flying is assigned the integer 0, pecking is assigned the integer 1, and sitting is assigned the integer 2. Now the data set is converted to 0, 1, 2, 0, 2. So this flying, pecking, and sitting are no longer considered as inputs, but rather 0, 1, and 2 are the numbers that we are going to work with. There are 3 class labels, so we require 3 bits to represent these integers. 0 is represented with 100, 1 is represented with 010, and 2 is represented with 001. Now we know what is one-hot encoding and how to encode using one-hot encoding. Now what are the steps to be followed when we want to code in Pytorch? The first step is to convert the class labels to integer encoding, where we assign an integer number to the values starting from 0. Then these integers have to be converted to tensors because Pytorch works only with tensors. And then these tensors are converted to one-hot encoding. So your class labels are to be converted to integers, and then from integers to tensors, and from tensors to one-hot encoding. Perform one-hot encoding using Pytorch. We first import Pytorch. Then we have to perform one-hot encoding, which is found in torch.nn.functional. Using the alias operator as, we create an alias name for torch.nn.functional as f. We next perform integer encoding. Here the data set is converted in such a manner that the class label is converted to a list of integers ranging from 0 to the number of classes minus 1. So this has to start from 0. The second step is to convert the integers to tensors, for which we use torch.tensor and pass the list of integers as argument. Then we convert the tensor to one-hot encoding using f.one-hot. The two parameters that are passed are the tensor that is to be converted and the number of classes. As shown in the output, this results in all the 5 values being converted into one-hot encoding with 3 bits. When we pass the parameters to one-hot encoding, it is possible to not give the number of classes, in which case the highest value found in the dataset is implicitly taken as the maximum number of classes. The number of classes is equal to the highest index plus 1, which is equal to 3, and the number of bits assigned will be 3. What if there is no 0 class in the dataset? Which means there is a value which is not found in this snapshot of the dataset. Then in that case, it would still give us the same value where 1 is assigned the one-hot encoding 010, and remember, only the highest index matters and the lowest index does not matter because it is automatically considered as 0. We have seen performing one-hot encoding when we had a transactional database kind of a setting. Then we took a computer vision dataset and saw where one-hot encoding is applied. Now let us look at an NLP type of a dataset which has 3 sentences. I am going to play. This is my house. I am going to my house. We have these sentences. The intention is to convert each and every word to a one-hot encoding. Here the categorical data are the different words in the sentences. So first we identify the vocabulary. The vocabulary is of size 9. There are 9 words and they are assigned integers from 0 to 8. Now how is the sequence encoded? The words are encoded first into integers. I takes the value 3, am takes the value 0, going the value 1, to the value 8, and play the value 6. We see a second example where the sentence is this is my house. The integer encoding would be 7452. There are 9 possible values and so there have to be 9 bits, and when there are 9 bits, when the integer encoding is 7, the 8th bit is a 1. For 4, the 5th bit is a 1. For 5, the 6th bit is a 1. And for 2, the 3rd bit is the 1. Having done multiple examples on one-hot encoding, I'm sure you will be able to fill in all the question marks. Thank you.